So you might be wondering how we go from standard form to vertex form when the a value isn't 1 or the b value isn't even. Because completing the square in that scenario would not be so simple. So we have a different option for those cases that involve just finding the vertex. So that would be step 1, is just to find the vertex, because when you're in standard form, we have a formula that helps us find it. So remember, if you're starting out in this form, ax squared plus bx plus c, then we can find the x coordinate of the vertex by using this little formula. Take negative b and divide it by 2a. Now that b is referring to b from standard form and a from standard form. So that actually is finding h for hk form, because remember h is the x coordinate of the vertex in vertex form. Negative b over 2a is the x coordinate of the vertex in standard form. So once you find it, that's h. Then the way we find the y coordinate is we basically evaluate the function for when x is equal to negative b over 2a. So a lot of the times I write that this way, f of negative b over 2a. That just means you take that value that you just found, you plug it into your equation for y and solve, and then that'll give you the y coordinate of your vertex. So that is actually finding k. And then you've already got a from your standard form, so then you just rewrite your equation in vertex form and just sub in your values for a, h, and k. Now remember, vertex form is the one where you have a out in front, you've got your parentheses squared, h goes inside the parentheses with x, it comes after a subtraction sign, and then you're adding k at the end. So once you find h and k from negative b over 2a and f of negative b over 2a, you just go ahead and plug those numbers in to your vertex formula. Now let's go ahead and try it with example 4. So if you notice, I have example 4 twice because I wanted you to see how it works using either method. So this example would be ideal for completing the square since a is 1 and b is even, but it can also work by simply finding the vertex. So let's see how that happens. So a in this case is 1, b in this case is negative 10, and c is 8, because that's what these numbers are when you are in standard form. So if I want to find the vertex, I can use the formula for that. So I can say that the x coordinate of the vertex is going to be negative b over 2a, which in this case would be negative 10 over 2 times 1, or positive 10 over 2, which is 5. So I now know h, because h is the x coordinate of the vertex, which I just found to be 5 by evaluating negative b over 2a with the a and b values from standard form. Now what I do to find the y value is I take f of 5, right? So this is the f of negative b over 2a I was talking about a moment ago. I take that number that I found for negative b over 2a, which is 5, and I sub it into the equation for x to find y. So I'm going to do 5 squared minus 10 times 5 plus 8. So that's 25 minus 50 plus 8, which is negative 25 plus 8, which is the negative 17 that you may remember we had earlier when we solved example 4 by completing this square. So what I just basically found is the y coordinate for the vertex, which is basically k. So once you find h and k, remember a is the same for all three forms, so you already know a, you can plug that into vertex form. So I'll write again the standard vertex form and then show you what that looks like when I plug all of these things in. So a was 1, h was 5, and k was negative 17. So this here is my vertex form. You can see it's the form that highlights the vertex. Standard form highlights the y-intercept, so for this function that's 8. Vertex form highlights the vertex, which for this function is 5, negative 17. Now let's try one where the b value is not even. So a is still 1, which is nice, but the b value is not even. So That means we might have to deal with some fractions. So notice A is 1, B is 9, C is 2, right? I'm starting in standard form and I'm trying to go into vertex form. So I need to find the vertex by finding that x coordinate, which we can find by doing negative b over 2a, which in this case would be negative 9 over 2 times 1, or negative 9 halves. That's h. So I just found h. Now what I'm going to need to do is take that number, plug it in for x to find y. So I call that f of negative b over 2a, which in this case would be f evaluated at negative 9 halves, which is negative 9 halves squared, right, x squared, plus 9 over 1 times negative 9 halves. Whenever I'm working with fractions, I put all my whole numbers over 1, and then plus 2 over 1. So when I square a fraction, I square top and bottom, so I get positive 81 over positive 4, because I was also squaring the negative, because that was part of my h, or part of my negative b over 2a. Then here I multiply straight across, so negative 81 over 2, and then plus 2 over 1. So I think what I'll do is get a common denominator with all of these fractions, so I can go ahead and add across. So I get 81 over 4 minus 162 over 4 plus 4 over, whoops, I should multiply this one by 4 over 4, just kidding. So 8 over 4, right? That equals 2, but has a denominator of 4. Okay, so then when I subtract 81 minus 162, I get negative 81 over 4 plus 8 over 4, I get negative 73 over 4. So now I've just found k. I found the y coordinate of this function when x is negative 9 halves. So that's the y coordinate of the vertex. Because remember, these 2 points go together to create the vertex. And a is the same as it is, it's the same in standard form as it is in vertex form. So all I have to do now is plug all of these values in to vertex form. So for my vertex form, I get y equals a, which is 1, times x minus h. H in this case is negative, so it's minus negative 9 halves squared, plus k, which is also negative, so minus 73 over 4. Now here, because I'm subtracting a negative, that'll cancel out. So my final vertex form would be y equals the quantity x plus 9 over 2 squared minus 73 over 4. Why don't you guys try this process with number 6? Okay, so for this one, it was started off in standard form with an a value of 3, a b value of negative 24, and a c value of 44. So to start, we want to find the h value of our vertex, which is the x coordinate. We can do that by evaluating negative b over 2a, which ended up being 24 over 6, which ended up being 4. I then take that 4 and substitute it in my equation for x to get y. So I ended up with 3 times 16 minus 96 plus 44. That all ended up equaling negative 4. That's the y value of my vertex, or k. So then I take these numbers of a, h, and k, and I plug them into my vertex form to get my finalized answer. Always remember, by the way, that the h is the opposite sign because it comes after a subtraction. So h was positive 4, but in my formula it says x minus 4. We saw a similar thing with that back in example 5. H was negative 9 over 2, but in my vertex formula it became positive 9 over 2. So in our last example, we're going to take a look at a standard form equation where the c value is 0. So sometimes this form will throw students off because they're used to seeing 3 terms in standard form. If it's missing the constant, all that means is that the constant was 0. But because there are no parentheses, that's how I know this is in standard form. A is always the number in front of x squared, so a would be negative 0.5, and b is the number in front of x, so b will be 3. So I have enough information to find my vertex, which is what I will do first. Again, my vertex, or the x coordinate of it, is what I get when I evaluate negative b over 2a. In this case, that would be negative 3 divided by 2 times negative 0.5. Now remember, negative 0.5 is basically the same thing as negative 1/2, 1 over 2. So I'm just taking half of 2, or I'm multiplying 2 over 1 by negative 1/2. At any rate, that's going to end up equaling negative 1 because half of 2 is 1, or 2 over 1 times 1 over 2 cancels to be 1. Of course, it's negative 1 because it was a positive times a negative. So then I get negative 3 divided by negative 1, which equals 3. So that will be my h value for this vertex form of a quadratic. My h value is 3. So now to find my k value, I take that h value and I plug it in for x to find y. So I do g evaluated at 3. So I get negative 0.5 times 3 squared plus 3 times 3. So I get negative 0.5 times 9, right? Because I do exponents first before I multiply. So I square the 3 to get 9 first. Then I'll multiply that to the negative 0.5. Over here, I'm just multiplying 3 times 3, so I get 9 again. So I have negative half times 9 plus 9. So you can do this in a variety of ways. Maybe I'll try thinking of it in terms of a decimal, right? Half of 9 is 4.5. Or you could think of this as 9 times 5, which is 45, but I'd have to add a decimal, which would be 4.5. And since it's a negative times a positive, it's negative 4.5. Negative half of 9 plus 9. So then when you add negative 4.5 plus 9, you get positive 4.5, the positive half of 9. And that's my y value evaluated when x was 3, so that's k, the y coordinate of the vertex. So again, I now know h and k, and I knew a from the beginning, because a in standard form is the same a as in vertex form. And so all I have to do now is plug in my pieces. So my vertex form equation for this one would be y equals negative 0.5 times the quantity x minus h, which is 3, squared, plus k, which is plus 4.5. And there's our final answer for number 7.